So indeed, I will talk about Kafka and how to integrate it with GraphQL to basically send events from the backend straight to the front end using subscriptions. So first, a bit about me. I worked with Open Web for 3 years. It's a consultancy company, so most of the time I'm working as a contractor with different companies. This last few months was a bit Payconic. They have like payment apps where you scan QR codes and then can make payments, and you can also make payments to friends and stuff like that. And then the work I'm doing is most of the time it's backend services that are relying a lot on Kafka. Most of the time during my professional career it was all about Java. Like 4 years ago, I started with the bank with the Kafka implementation, and I really liked how Kafka worked and their API and how customizable everything is. I learned about GraphQL, well, I think earlier, but I started experimenting with GraphQL 1.5 years ago. I still haven't used it in production. I really want to, but yeah. So just a quick question, how many people here are using GraphQL currently? Yeah, so it's about half, like they said in the keynote. How many people know Kafka? Okay, so that's even more. And how many people are like really involved with doing stuff with Kafka? So that's just one. So I will go quickly to Kafka because like Kafka is like really big, and there has been a whole summit about Kafka just a month ago, also in San Francisco, and all the presentation online. So if you are really interested in Kafka, you can view them. And then there's also Clojure that I learned about like 3.5 years ago, and a lot of my passion projects, I really like Clojure, and so I do them with Clojure and ClojureScript. Like I said, I also have like this Rust library and also busy with Rust, and there's also somebody busy with making some kind of a dynamic proxy with Rust specific for GraphQL, where you can also, for example, put it on your authentication and then let us go to different endpoints based on the authentication. Too long on this slide. So that's basically it. So that's the overview. So quickly to Kafka, then I will show how the demo project I set up, how it's the components of that. I will talk about some GraphQL interactions that are implemented. Then I will do a demo. And then after the demo, I will also show some tests I've run and what conclusions can be drawn out of that. So why Kafka? Well, like Matt said, with the front end, with a lot of different back ends, you basically also have something like this. But in the back end, you have the same thing with different backend services. They all need to talk to each other, and if you don't have a common language or a common place to put those things, it quickly becomes a mess. So if you put like Kafka in the middle, then a lot of those things become much easier and decoupled. And it's also nice that in the case of Kafka, it's much like a message bus. So it's also asynchronous. So one of the parties can just put their data on Kafka, and then everybody can take the data from it at their own ease or when they want to. So also if you have some kind of process that has been down for a half an hour or something, it can just reconnect to Kafka and just continue where it was left off. And Kafka is just managing where it was left off and stuff like that. Only there is something to use REST with Kafka, which isn't not working that nice. But for GraphQL, there isn't really one. There are, well, some other experiments like my own experiment, but nothing out of the box. So I thought that's interesting to compare those two. So a bit more about Kafka. Kafka is working with topics, and then each topic have different partitions, and that's one of the ways that they are able to really scale a lot. So how it usually works, that each message has a key, and depending on the key, it lands in one of the partitions. So for example, if you use the partitions, if you use the username as key, then every message that's for that user will go to the same partition. And that way you can scale out, but still for that user, the order is the same. So that's nice. What's also nice with Kafka is that the producers and the consumers are decoupled. So the producer can just write to Kafka, it gets from Kafka back that it's successfully written to Kafka or not. And if not, then it can retry. And the consumers can just go their own way, connect to Kafka, find out where are the partitions, and get them. So for now, for microservice, it's like a loading term, so it's difficult to use that. But in this case, because we use Kafka as our main source of truth as a kind of event, so basically everything is either consuming from Kafka or producing to Kafka or both, then most often there's some kind of derived database, because Kafka is very good at streaming stuff. But you can't say, give me the latest event of user X or something like that. Therefore, a database is used. In this case, I use Postgres, but it could also be some other kind of database. And then mostly with microservices, there's something else. And in this case, of course, the something else is GraphQL. So an overview of the demo project. So yeah, it's a web application. So the client retrieves all the information from the front-end servers, which is basically just some index HTML and some compiled JavaScript, which in this case is by reframe. So it's a closure script library, and it's just packaged there and extracted. And in the library, there's an endpoint configured for GraphQL. So that sets up a WebSocket to consume from the GraphQL endpoint. It also does a couple of more things, but I'll get back to that. Then there's like the Kafka cluster to share all the messages from the backend. And there's a command handler that's handling the command. So it's like a CQRS style. Once you have a subscription, you put in your command, and eventually something comes back, and that's then sent to the client. There's just 4 topics for this demo project with all kinds of events. So there's the commands topic where all the commands go, and then it's a bank simulation. So you first need to open an account, and then once you have an account opened, you can transfer money. Then there's the feedback from the account creation. So it can either fail or succeed. It can basically only fail when the randomly generated account number is already existing, so that chance is pretty low. Or you can transfer money, and then there's more cases when it can be failing, because you can have not enough money on your account, because by default you can have 500 euros in debt and not more. And then there's the balance changed. That's like a derived event. So if the money transfer succeeds, then if it's an existing account within the system, then that balance is changed. And if the money by the party where the money is going to also exist in the system, then that's also a balance change event. And all of these topics have a retention of main one. That's like the Kafka thing to say, just never delete this topic. And that kind of makes it event sourcing, because then you can throw away all the database and build it up again based on these events. So for the GraphQL part, I'm using the GERARD database. That was developed by the Walmart labs. They also use it in production. But they don't, and they also always test it first in production. But they don't actually use subscriptions themselves, so that's quite interesting. And you can also see how it's built up. So when requests comes in the server, then the schema provider is kind of redirecting it to different resolvers, and then those resolvers are separated into 3 services that are like microservices, and then some of the microservices have a database with the view of the data, and there's also the money transfer service that's more simple, that's just putting the message to Kafka and just waiting till something comes back. And I will talk some more about those different services. So one of the simplest things with such a system is that you're just building up your database, and your queries, well, that's kind of like the same like you used to when it's a normal application, the only difference is that the database is created by updates from Kafka, and then immediately you can send back the current state. So that's an overview of the transaction service. So the client does either do a query or subscribes to transactions. Then when it's a query, then it's a query directly on the database and gets information back. When it's a subscription, then it will be handled by a WebSocket, and then any incoming balance change event will be transferred to a transaction and then sent to the client. Then there's another kind of subscription that's filtering a stream of events. This can be used for like the derived events when there's no clear trigger, because especially with the money change event, it might be that you're getting money from someone else, so then you're not the one that's triggering, but you still are interested in those events. So what we then do is just listening to Kafka to all those events that are coming in, which is basically like a hot stream, and then filtering out some of those messages, and then as it arrives from Kafka to the server by the WebSocket, it's sent directly to the client. And another kind of case is like I told, like the command and then reaction. So in this case, it's either I want to open an account, and then you get back that the account was opened or not by the topic specific for that feedback, or I want to transfer money, and then you get back whether it succeeded or not. And that's always one thing, but you could, for example, also use this for something like I want to order food, and then you get back payment was received, we start to prepare, delivery is on the way, something like that, and then maybe even afterwards, how did you like the meal after an hour, like it was received or something, and then you can send all those messages to the client. So this is how the subscription looks like. So that's just sending the username and the password. It's important for the demo that the actual password will be hashed and it will be sent to some servers. But yeah, so you can put anything in there. And so when you're trying to get an account, you get back an IBAN that's like an account number and a token, and that's used to make the transfers. So for example, you can also have a wrong token, and if you have a wrong token, then also the money transfer will fail because you have a wrong token. But that's all handled by the command handler, so it's not directly in the GraphQL endpoint. So the GraphQL endpoint just translates the input to a Kafka message, and then the command handler will put some other kind of message onto Kafka, and that's picked up again. So this is how the account creation works. Yeah. So like I said, if first I make a request to the subscription, then it's checked. Oh yeah, it's also checked whether the password is fine, because currently they are stored in the GraphQL endpoint, which might not be the best ID, but that's how it's currently working. So also when it's the wrong password, you immediately get back, and it's never going to Kafka, and then it's making the request and then listening to responses. And in this case, also in the front end, because it's now there will always be just one message. As soon as that one message has arrived, then it's canceling the subscription. So this is the same thing in the sequence diagram. So you subscribe to the stream for creating accounts. Then in the transaction database, that's in the GraphQL endpoint, it's creating an account with a random UUID. That UUID is sent to create an account, and also so that it can be matched to what's coming back. So then from the command handler somewhere down, then really like the account is created. And that's then filtered on UUID, so only the one event that a client sent out is sent back. And then it can store the token and the bank account, and then end the subscription. Money transfer, it's like almost similar, only there's no database involved. So it's just there's more data there, so there's like the token and the amount and description and stuff like that. It's all, again, transferred into a Kafka event thing, put onto Kafka, and then it's waiting for something to come back. So now it's time on the demo, and this is actually the first time it's running live and not yeah. So if you, I should be able to zoom in. Oh, but not on the actual URL. Yeah, so it's, yeah. What's the easy way to, yeah, so basically it's GraphQL.KLIJS.tech, and the front end is now hosted with Netlify, and the back end is running somewhere in Frankfurt. What you're now seeing is the transaction from the company account. I can now log in the account I created. Yes, and then on my phone, I also logged in with another account and trying to make a transcription, and that's now there. So I just did it on my phone, it's going over the internet through all the servers. And that's a nice thing if you also go to the website, so just transfer some money to the same account, which can be easily copied, because when you're entering, it's now just one. This is the one you need. And if you transfer some money, there are like 3 power banks to give away for the first 3 persons that succeed. They should, just like the other message, show up here. So this was mine. And so the next 3 to put forward, there's the power bank. And while that's running, I continue with some of the tests I did. Yeah, so yeah, it's nice, it's working, it's fast, but that's just like one time. So before like really going out and telling to people, hey, I want to use something like this, I wanted to do some tests. So I made a kind of production-like way. So there's some redundancy in there with 3 Kafka brokers, so the data won't get lost. There's some encryption on the Kafka part. Then I kept increasing the load. So I wrote some closure that had like WebSockets, and then they were transferring money at most 4 times a second, and then every X amount of time I was adding such a generator. So then the load kept higher and higher, and then eventually it starts to break somewhere. And yeah, I was just very interested, where shall it break? And it's also interesting to see what happens when it runs for a long time, because it's nice that, well, you just put it up and then it works, but what, like after an hour, or ideally even after a week or something. But that's taking too much time. So each run is taking 100 minutes if everything goes fine. And I also wanted to know the end-to-end latency. So there's also, like every second, it's also making a transaction to measure the end-to-end latency while running the test. And in this specific case, I was playing a bit around with a Kafka configuration that's called linger MS. And that's basically how long the producer waits till really putting it, really sending it to the server. Because if you have a lot of messages, then it's much more efficient to send a lot of messages with one really long one raw request than instead of sending a lot of small messages. So these are the results on the end-to-end latency. What you can see is this is like also inflicting both the command handler and the GraphQL endpoint. So if you put it to 0, that's like the most extreme case, then everything is immediately sent to Kafka. So then you get a low latency because it's end-to-end is just 100 milliseconds. But you run into problems very quickly when it's not scalable anymore. When you put it to 100 milliseconds, then it will keep going fine a lot of the way. What's also interesting is the total messages per second. So with 100 milliseconds, it can, well, just over 300 requests per second. And the other ones are lower. So that are 300 transactions made by all the generators. So I also checked the CPU during the testing, and then you can also see that it's really kind of stressful for the GraphQL endpoint to put all those messages directly on Kafka, checking whether that message with that single one was really there and then getting it back. And if you put it to 100 milliseconds, then it has a lot less to do because then it's sending multiple messages in one go. So a bit about scaling, because 300 requests per second might be enough, especially if it's like an internal tool that you just use for admin purposes. But if you want to use it in production and you are really big, then you might run into problems. And then, like I said, with scaling, so Kafka has these different partitions, so you can make it to the command handler that it keeps using the same key. So then if it doesn't matter which request I made as a client, then also on the topic coming back, it's still on kind of the same partition. And I could make GraphQL endpoints that just read specific partitions, and I could make multiple of them. But yeah, if you start to scale dynamically, you still have this kind of problem that you then connect it to one, and in the meantime, on some other GraphQL endpoint is the event you're interested in. Or you, even if you transfer to the other endpoint, you might be too late because it's a hot stream and then it won't work. So what we learned, there are like 3 kind of ways with an event sourcing setup in which you can use GraphQL with Kafka. So just basic queries on the displayed state. Or you can just listen to a stream coming in with some kind of filtering. Or you can have like really a command and then getting all the actions back that are resulting from that command. It's a limited demo because there's like no authentication, authorization, or whatever in it. Because like there is the token that you need to subscribe money, so nobody can easily subscribe money from someone else. But everything else is in the open. So if you want to use something like that, it should be different. And scalability is, yeah, like I said, pretty tricky to get it right because there are some ways to handle it. It's also interesting. There's also something in Rust that you can, when you're connecting with GraphQL, it can get the token and then kind of proxy you to different endpoints. But yeah, it keeps tricky. I'm not sure if anybody tried to get to the. Oh. So there's still nobody. So maybe I try to. No, it didn't work, right? No. Does anybody know for a Mac an easy way to display it big? Or sorry? And then is this visible? Or oh wait.
Is the login form also the create form?
Yeah, there's a few now. There's already more than 3, I think. No.
So I did the first 2 there. Power bank please me there.
Yes. So there's 1 power bank for you. And see if somebody else gets, and then I get to the end slides. So there's some links in there. So that's my Twitter handle. There's also like the background story, because it's like a very long story how it came to be, because there's first like a workshop and then some meetup, some other meetup to put everything together. Then there's also a LinkedIn slide share, so there we'll also put the slides from this one. Also interesting is the REPL.net. It's really about Clojure. And it was very interesting, the latest episode was episode 30. Then they have kind of like the same architecture setup, but then, yeah, so the same thing, like almost the same thing, also with Reframe, also with Wilma for the CSS, but they're running it really in production, so that's interesting. So are there any questions? Yeah.
Do you feel like you have to use subscriptions to get the benefit of using Kafka?
So the question if you have to use subscriptions, I don't think so, because it's just, it stands out as like one of the features of GraphQL, and it's nice to play around with. But you could of course just split it and just make a mutation, and then if the mutation happens successfully, then it's basically just feedback if it's sent to Kafka or not. And then you have some other kind of query or something to check back if it's got to the needed result. That could be fine. And then it's easier to scale. And I'm now just tried out the Clojure variant of the backend, and I want also to use the Rust variant. I'm also busy with the Java Spring Boot variant, and then I can use the stuff to compare them also for performance and stuff like that. And also in Rust, they are busy with the server also implementing subscriptions, so they can also use Rust. Rust is in this respect maybe more interesting also, because it's like also typed. So maybe eventually I can make something that, so for Kafka there's also like a typed thing with schemas that gets the schemas from that registry, and then sort of automatically creates an endpoint based on those things. That would be very interesting, probably. So then you need just some basic configuration, because these are the topics I want to consume from, and just generate a Kafka endpoint for me for GraphQL on this. It should be possible, I think. Any more questions? Okay, that's it, I think. Or, yeah, there.